Hello, I'm Steve Reyes, Product Manager for Anritsu Company. What we're demonstrating is the ability to perform differential noise figure measurements with the VectorStar VNA. So the approach to differential noise figure is similar to single-ended measurements in that we're using a cold source method. The difference is that we are identifying some of the correlated noise powers that can be present in a differential measurement that may be contributing to the uncertainties in your noise figure measurements of differential devices. But in general, the approach to differential noise figure measurements is to first take a measurement of the DUT, obtain the SNP file of the DUT, then we set it up for noise figure measurements. And in this particular case, when we switch over to differential measurements instead of single-ended, you've got three choices in terms of the types of methods that you want to do your analysis. So what we provide is the ability to do uncorrelated method, a combiner or a Balun method, and a correlated method. The difference is that we are correcting for the correlated noise powers that you will find in a typical DUT. So getting back to what people have been doing in the past, since this is a brand new, unique capability that we're providing with VectorStar, what people have been doing is treating their differential device as two single-ended noise generators. And they'll make measurements on both channels, get the noise power and do an averaging and get a number from that. The problem is if the device is not well isolated. If it's isolated, then that single-ended, dual single-ended measurement should be good enough to characterize your device. But if you do have some cross-correlation and some isolation issues, then you are going to introduce some uncertainties in your measurement. So what people have been doing in the past, in addition to a single-ended measurement performed twice on the channels, is to use a Balun. So in this case, it simplifies things because you can add your Balun to the output of a DUT. You've got your single-ended output where you can make your measurement, and you get your one number. Of course, one of the things you would want to do is to de-embed your Balun, and you would want to do that with an SNP file. So that is what people have been doing. You will correct for the imbalance of your combiner and do some corrections. The problem with the Balun approach is if you don't look at the common mode crossover into your single-ended output, then you're going to also induce some uncertainties due to the correlated aspects of the combiner as well as the DUT. So getting back to what VectorStar now is providing is the ability to characterize, to identify and characterize the correlated noise powers that are in your measurement system and then take them out. So going back into our measurement, so now that we have entered the noise figure measurement mode, we select whether it's uncorrelated, a Balun approach, or correlated. So I'll just describe the correlated method, which is basically using a preamp, in other words, a composite receiver that boosts the noise floor of the DUT above the noise floor of the VNA. And so you start off by first characterizing the receivers with your source from the VNA. So in the case of a differential measurement, we are using two receivers, our B1 receiver and our B2 receiver. Our receivers are coherent in that we can then analyze the coherent noise that we are measuring and identify the correlation aspects of this. So that's what we're doing, is we're characterizing the two receivers, B1, B2, that is also including the preamps for both channels as well. So once we have that identified, we then terminate the inputs of the receivers and get a composite noise floor for the receivers on both channels. Then that's our final calibration step, because next we simply make our measurement by attaching the DUT and attaching a load at the input of the DUT, and whatever additional noise we are now measuring from the DUT, that's our measurement. But again, going back to what we're really doing is identifying the correlation that occurs in that DUT in order to give us a final differential noise figure number. And basically, what we've been finding is without that correlation correction, you can get anywhere from a few tenths of a dB to a few dB of differences. So it's something that is going to continue to be an increase of interest, since many people are transitioning over to differential devices and differential systems in order to improve on the low noise sensitivity capabilities of system receivers and amplifiers that are being developed these days. So the new, the 5G systems, the new radar systems, etc., all transitioning over into differential devices are now able to make the characterization, noise figure characterization in differential mode, rather than just simply assuming that is perfect single-ended measurements. Okay, and that's the information that we have available. And if you would like more information on the capabilities of VectorStar in performing differential noise figure measurements, please visit our website, and it's at www.anritsu.com. Okay, thank you for attention. Goodbye.